To build this size of digester, we need 1,200 bricks. We are going to use what are known as the interlocking blocks because of the advantages of being stronger and much more economical in terms of the number of bricks. We use half the number of bricks that we use for the fired bricks. And the strength of this is twice as strong. It is 4 newtons compared to the 2 newtons of the fired brick. We have our machine here, which we are going to use for making these blocks, using the mixture of marram, sand, and cement. We are going to use 6 wheelbarrows of marram, 3 wheelbarrows of building sand, and 1 bag of cement. In order to make this mixture workable, we sprinkle some water. This improves the workability as well as improving the holding capacity of the cement to the marram when the block is made in the machine. We just sprinkle water to make the soil moist but not wet. The water content should not be much, because if it's much, then it again increases the adhesion of this size of this block to the machine. We normally use a polythene paper so as to reduce on the cohesion of the soil to the inner size of the machine. Also, polythene paper helps to make the size of the block relatively smooth. We are on day number 2. Construction of this structure is expected to take 8 days. We normally don't use a concrete foundation. We normally use mortar because we don't have much force exerted on this foundation compared to the other digesters, in that it's a spread foundation. This helps us to save on the concrete and the cement which we would use when we are using the other ordinary digester.
The measurements from the reference line and is 232 centimeters. The pit itself is 7 feet deep.
We use what is known as a radius stick that controls the radius of the digester, and also creates a dome as we go upwards. We would save about 30% of the cost of the original design. It contains 12 cubic meters of manure, of which 6 cubic meters is cow dung diluted with water with the same amount. This is a renewable system. When we first feed it with the 12,000 liters today, we shall continuously feed it every day, such that it will have continuous production. And this type of digester will give us about 2.6 cubic meters of gas every day. When you put up the digester, you are actually trying to save the environment by saving the trees. The soil that you use for making this is non-productive soil, the one which comes from the pit, the one that we use. So you don't disturb the top soil. We are now on day 4, and we are working on the construction of the upper part of the digester, which is the gas chamber, which is going to take us through up to the following day, which will be in day number 5. On this digester, there is no need for use of a beam, because these blocks automatically interlock and they don't leave a space in between the two sides of the gas canal where a beam would be necessary to bridge the gap. Normally don't need external pressuring because of the stability and the adherence of the bricks to each other. We normally have at least 5 hooks with him, such that should it be a rainy season, he can use the 5 hooks towards the completion of this gas chamber. When you compare with the traditional biodigester, a mason normally would have about 30 hooks used continuously from the beginning of the construction up to the end. Because of the interlocking nature of these blocks, it will create a very stable structure whereby we don't even need to use chicken mesh because of the stability of this structure. Today we are starting the construction of the expansion chamber of the digester, which will also take us day 7. Complete expansion chamber should normally have a manhole cover to avoid any accident that may result from the uncovered manhole. It's the storage for the gas. And now this expansion chamber on the other side has got an outlet canal. This charges the slurry from the digester. day number 8, which is our final day, under which we are doing the installation of the pipeline and the appliances as well. We are laying the pipeline using the PVC pipes. The advantage with these pipes is that they are not susceptible to corrosion. And we are using fittings of GI so that the fittings are strong and leak-proof. It has to be inserted into a trench and buried underground so that we maintain a low temperature on it, at the same time prevent mechanical damage which could occur to it.